Awesome. Good morning, everyone. My name is Kyle Escamilla, and I am the training coordinator for AVEVA Select California. I want to thank you for attending our deep dive workshop today focused on cybersecurity and AVEVA cloud products. After the presentation, we will be having a short Q&A. Yeah, cool. We are recording this, but any sensitive questions you ask will be protected. And now I'd like to introduce your presenter for today, Mike Brost. Mike is a senior principal technical sales consultant for AVEVA. Good morning, Mike.
Morning. All right, so let's get right into it. So the basis of this presentation is to design a defensible security framework for getting data into a cloud environment. And so, why do we want to do this, right? Getting data into the cloud. Well, we have lots of consumers of OT information. OT meaning I'm talking about control network information. And most of the time, or at least it should be in an isolated path from the business network and from the cloud, right? So we want to be able to get information up to these either internal users who are cloud-based, and that's like, if I want to get information on a phone, well, a phone is a cloud device. It's living in the cloud already. And it's a bad practice to teach that phone how to weave its way through all our intrusion protection that we use to protect our OT environment so that it can see that information. A far better strategy is to securely and effectively push that information out to the cloud so the phone can get it where the phone lives, right? Same thing's true with your browser, with your, accessing from your home, looking at data from your, hotel room, whatever, right? And even getting information to external organizations, right? Like you may want to share inventory levels to a supplier, or you may want to have the ability to see stuff to you're a contract provider of services, and you want to be able to share to selected customers their information and be able so they can see what you're doing, right? And it's really important that you not violate your intrusion protection that you've put in place. Your OT network should be isolated from those consumers. In other words, their logins, their usernames should not work on your OT environment, right? You shouldn't be granting them access point or a username, which if they got on your OT environment would allow them to log in, right? Right? And when we transmit information to the cloud, we want this to be secured, what's known as secured at rest and secured at motion, right? Which means it's stored encrypted, it's transmitted encrypted. At AVEVA, we even go further than that, and we'll talk about that in this presentation, how we ensure that the data you send is the data the cloud has. Because that's really the threat to the cloud, right? The cloud is a very secure place once the information is there. The real threat is someone can change it before it gets there. And now you base information on erroneous data, right? Someone's just playing with it and decides to screw up all the numbers and make them look weird, right? Whatever. The threat is really that data being intercepted and modified before it gets to the cloud, right? And this information should only be allowed to be sent from the OT network. The OT network should be in total control of this. No one in the cloud should be able to say, oh, I want to go get this piece of data that you haven't authorized to be sent, right? So there should be no mechanism from the cloud to reach in and grab data that the OT network has not previously decided to send, right? And it should be able to be routed through all the firewalls and DMZs and all the levels of intrusion protection the organization is deemed appropriate for protecting itself, right? And if designed properly, that we should be able to, the cloud offers us a lot of capabilities. We'll talk about that in this presentation, but I should be able to consume that information back down that same path without violating all my intrusion protection and without putting my OT network at risk, right? And probably the key here is that when I choose to send data up to the cloud, that information I'm sending should be bound to the sending device, sending entity. There should be no way for me to go in and simply unplug one computer and plug in a different computer, whether that's done electronically or physically, and just start spoofing the data that the cloud is receiving, right? It shouldn't allow that to happen. And again, this is all the things that we think are important for getting information up into the cloud. So if you look at a conventional network architecture, I realize this is a kind of a busy slide, but just look at the colored networks here, and we can see in the blue network, we have our device network. Right? This is actually our most vulnerable network that we have, right? Most devices are very insecure, right? They simply require a properly formatted message, and they'll tell you everything they know about themselves. If they are at any level of security, then it's an access, no access level of security, right? They can't arbitrate between changing the product code on the bottling line from grape soda to cherry soda and adjusting the high alarm limit on the ammonia storage tank. Once you can write to one thing, you can write to anything. So we need to be very careful with that network. Redundancy is a very important aspect of cybersecurity. We should be able to operate so that the system can absorb change, absorb patches, absorb updates, and still function. So the orange network here is our OT network. That's the one that we're really trying to protect in this framework, right? We're going to send that data out of the OT network through a firewall into a DMZ. In the DMZ, we're going to retransmit that information through another firewall to the business network. On the business network, we may go through a proxy server, which then goes through a firewall, which then ends up in the cloud somewhere. So there is no direct connection from the OT network to the cloud, right? You should not have a firewall on top of your OT network, and at the other side of that firewall is the wild and woolly internet, right? You should have to go through multiple levels of intrusion protection to get there. And this puts a big barrier in sending information to the cloud for most architectures, right? Because they don't have the facilities to weave through this level of intrusion protection, right? And so as we begin to look at this, right, you know, we're sending data from the OT network up. First thing, our first destination is up into the DMZ, and this should be firewall isolated from both the control and the business network, right? We have a component in AVEVA called our Insight Secure Link, and it allows us to route that data through the software component that's up there, and that thing will allow it to change protocols and destination ports so that there's no way to go through both firewalls, right? You have to go through the DMZ to get there, right? And a lot of components that we have support this, right? We do it with local historians, we have InTouch Access Anywhere Secure Gateway, right? The InTouch Web Reverse Proxy, OPC UA Gateway, OI Gateway, all these things. Any gateway product that you have that external things are going to access should live in the DMZ. They should not be on the control network. We shouldn't allow any foreign actors entering into our control network unless it's going through a known gateway, which is intercepting that transmission, repurposing it, and sending it down into the OT network in a fashion that the person trying to use it does not have capability of penetrating into our OT environment. And as we move data up into the business network, right, you know, we don't want to violate any of our IT policies, right? We want to have all the security policies that IT thinks are important. We should just embrace those. We shouldn't care that they're putting all this stuff on there, because our environment for transmitting up there is totally compatible with what they want to have done, right? And so this is where you have things like your enterprise historian, whether that's the AVEVA one or the OSI or the AVEVA Pi one. But everything should be exposed up to the business network, and this should be totally domain isolated from the OT environment. No username on the business network should ever function on the OT framework, right? There's no reason for that. And then as we get data up into the cloud, we want to be able to send that data from now the business network up into the cloud, right? And we want to transmit that into the cloud in a very secure fashion, right? So the first thing that everything should be certificate based. In other words, with certificates, we now know who is on either side of the conversation, right? and those certificates are bound to the sending entity and the receiving entity, so that you can't spoof it because you can't regenerate the certificate, right? And so with AVEVA, we basically send that data up into the cloud, but we split it into two components. We have a metadata component, which describes the values and what they're called and maybe where they're located and what their purpose is and their engineering units and their scaling and all the stuff describing the thing. And all that's attached to a GUID. A GUID is what's known as a global unique identifier. It's something that can never be repeated. It can only be generated one time, and no one can ever regenerate it again. That the actual process data values are all reduced to a number between 0 and 1, and they're then sent to the cloud attached to that same GUID. So the two transmissions are completely independent of each other, and they're both encrypted. They're both secured with TLS 1.2, and they're both attached to certificates. And so if you could break into that transmission, which currently you can't, without massive supercomputer capabilities. If you could do that and see what was coming, all you'd get is a number that's between 0 and 1 for everything. So you would not be able to distinguish what value this number is associating with, because all the numbers look the same. And when we send it up into Insight, we store that into two separate databases. So data is stored into two separate databases. Both of them are encrypted. And when users want to look at that, the cloud environment puts the numbers together and gives them the value that they want to see. And because of this whole mechanism that we've put in place, there's lots of capabilities that the cloud is doing with that information. We have news feeds, we have automated analytics, we have machine learning, we have AI functionality going on up there. We've got all this stuff that could be useful to the OT environment, to the operator running the asset. And he or she can consume that information through the same maze of intrusion protection that we put in place without violating any of the security protocols that we've deemed appropriate to protecting our organization. Right? So when once data is up into the cloud, it's enriched with all this capability, right? So the historian is up there for it, just simply presenting this data with a time series capability to it. We have OEE calculations for machine performance. We have a news feed for unsupervised analytics. We can do condition-based analytics. We can do guided analytics for asset-specific based on AI technology of, I know you're a pump, so I can understand what a pump is. I know you're a compressor. I could then provide analytics on what a compressor, what's important to being a compressor, right? I even have advanced analytics, which is massive multivariate AI, which can be, neural network analysis of information from hundreds of tags together. Because, in the cloud, we have really unlimited computational horsepower. And the challenge has always been, how do we get the data in there to leverage the horsepower that's available? And how do we then consume the results of that analysis safely and securely? And then we have the ability to put dashboards on this information in the cloud that can be shared to cloud users, or can also be sent back down to the OT network for consumption there. Process graphics can be animated and displayed and shown to cloud users. And you can also securely from the cloud distribute data to all the cloud consumers, whether that be an external organization. It's all multi-tenant, so that you can say, you're allowed to see this group of tags because that relates to you being a supplier to me, or you're allowed to see this group of tags because that relates to your component that I'm hosting for you and managing for you, right? And you can get at this data with OData interfaces and a REST API interface from any external application. So a major component of this is a downloadable product that the cloud provides us called Insight Secure Link. And what this is that this is a reverse proxy or product that is pre-built by AVEVA. It will eventually send data to the cloud via 443, which is the internet secured IPsec port. But it's only an outbound transmission at this point, right? You don't have to allow it to consume data backwards, but you can. But it doesn't allow any origination of this communication from the outside. It only allows origination from the bottom up, so that the OT frame network says, I'm going to make a connection to the cloud. Until that, no connection to the cloud exists. No way that can the cloud reach through this stuff and say, oh, I want to connect to the OT network. Now the cloud has no idea where the OT network is, right? And it supports going through a DMZ, so you can daisy chain these guys together and be able to weave them through all your intrusion protection. And they'll change ports and all the things that your network firewall guys want you to do to secure that no transmission can go directly through all these firewalls. Otherwise, what's the point of having the multiple firewalls in the first place? If you have to violate the firewall by saying, oh, we're going to punch through this single port through these 3 firewalls, you've ruined the purpose of the firewall. And more importantly is that the configuration of this is all maintained by the AVEVA cloud. So these things need to be whitelisted so that they know these are the endpoints I'm allowed transmission to, right? And I deny transmission to everything else. I only allow you to get at the things that we've whitelisted them to be able to access. And all that burdensome administrative work is simply taken care of for you, right? So it will block transmission to everything else, right? So if I try to get to something, like if I just try to, go to apple.com from my OT network, it says, no, you can't get there, right? It will not allow transmission to anything other than the AVEVA cloud products. And it allows you to, it will accept it, transmission from any local address, report it to a different port, which, so you go out one port into the DMZ says, oh, we're going to take all that information, send it out a whole nother port through the next firewall into the business network. One up there is going to go through the firewall on the business network. And all those firewalls deny through traffic with the same technology through all of them. They have to be weaved through the intrusion protection. It's very simple configuration here. And so graphically to show this, right, reiterate this, we want to get data into our Insight cloud. And we want to do it in a fashion that leaves us with absolute protection from intrusion back down into our OT environment. So we have a device that reads, in this case, we're reading a pressure. The pressure is 35.4, right? So that comes into our SCADA environment of AVEVA SCADA product. And it then gets contextualized. We now know that this pressure is tank A pressure, right? And its value is 35.4. We record that, say, into our local historian on our OT network, and that transmission is all certificate-based and encrypted, so that we absolutely are secured in the fact we know who's sending it and we know who's receiving it. And then we're still in the OT framework now, right? We haven't even left that environment. And then we're going to send that information up into the AVEVA historian, and it's going to be stored there and historized so that we can see it all in the OT framework, right? And then the AVEVA historian is going to be able to route that out through all 3 firewalls that we have here. And I've got customers with 6 firewalls, right? Doesn't matter. You can have as many as you want, right? And we're going to route that information out through all the intrusion protection, and eventually it's going to end up in the cloud, right? But there's no direct connection between the OT network and the cloud. You cannot just open a browser on the OT network and say, ooh, let's go hit Google, or let's do whatever, right? None of that is allowed. And so we weave that information up in through all this intrusion protection. And so The metadata that describes that value is also attached to a GUID and is then stored in a database up in the cloud. The database is encrypted, so it's secured at what's known as at rest. The transmission is encrypted, so it's secured in motion. No one can intercept this and change anything, right? They can't modify it in any way. They can't intercept it in any way, right? It's now totally secured in its transmission through all this intrusion protection that we put in place. And the data values now are reduced to a number between 0 and 1. So it's no longer 35.4, it's 0.354. And we attach it to a GUID, and that GUID is then, that data value simply attached to the GUID is routed through all the same levels of intrusion protection that we had before. And it ends up in the cloud as well, stored in a separate database, both of which are encrypted. So they're both secured at rest. The transmission of that is also encrypted. So they're both secured in motion. And someone wanting to see that from a cloud consumer, like I want to see that on my phone, I want to see that on a browser, I want to see that, from my hotel room, I want to check the status of things before I come to work, for my home, whatever I want to do, I can look at the cloud, puts the numbers back together and gives me that information as tank A pressure 35.4. So I now have this very effective and secure mechanism of sending data up into the cloud. Even if you could do what you can't, which is break all this encryption, break all this capability of transmission, all you get is nonsense, because you wouldn't know what you're looking at, and you wouldn't know what it was, and you don't know what it's for. But at the cloud, we have all this capability of analyzing this information and enriching it with understanding and knowledge and all kinds of cool things that we can do, because we have this great horsepower capability up into the cloud. We send data up into the cloud and we run it through automated algorithms that will then analyze it and tell us when it's doing different things than it normally has. We also will build multivariate systems. Like when we send all these tags to the cloud, the cloud will sit there and analyze all the tags against all the other tags and see which ones are related to each other, which ones should be tracking each other. If I have a pressure and a temperature in a vessel, they should track, and the cloud will figure that out. And then when they don't, it'll alert me and say, hey, it's no longer tracking, right? All automatically for us. So this is a wealth and richness of information that the cloud can provide with zero effort on our part. I mean, there's no configuration of this. There's zero effort. You just throw the information up into the cloud and it starts doing all this stuff for us, looking at changes in entropy of the information, looking for flat lines, looking for change in frequency, level changes, all kinds of things, simply by sending the data up into the cloud. And then that's presented in a newsfeed. And because we've originated this complex path of communication through all our intrusion protections without violating any of our intrusion protection capabilities, we can consume that information because the OT environment owns the connection. It originated the connection. And it can then consume this information back down through that connection and present that into an operator display for use for enhanced and enriched operator standing of how these assets are performing, how his process is performing, whatever it is that we have going on. So I guess, in summary, is that with this mechanism, it's literally the most secured and capable productized mechanism of sending information to a cloud environment with complete confidence that I'm not exposing my OT framework to intrusion from the cloud.